Hi, my name is Adam Ress, and this is the Charge Tapes, Lab 1 in Physics 2. So here's a table of contents. I'll start off with the introduction, then I'll go into the models, then I'll talk about the experiment, the code, talk about the discussion, and then I'll look at the conclusion. Introduction. So the goal of this experiment was to calculate the amount of excess charge in coulombs on the 8-inch piece of clear Scotch tape after using physical principles to give it a positive charge. Some of the physical principles we looked at were Newton's second law, Coulomb's law, conservation of charge, and free body diagrams. So Newton's second law is that the net force equals mass times acceleration. Coulomb's law is that F equals Coulomb's constant times the charge of the different points divided by the distance between those points squared. Then there's conservation of charge, and then free body diagram, which displays the forces acting on a body. So here's a quick preview of my main result. So the amount of excess charge on the U-tape was 2.92 times 10 to the negative 8 coulombs, or 29.2 nanocoulombs. The number of deficient electrons was 1.82 times 10 to the 11, and the number of deficient electrons per atom was 1.88 times 10 to the negative 7. Now for models. So some assumptions that we made was that the floating tape is in equilibrium, and that the tapes are point charges. We also made the assumption that the charge was evenly distributed between the tape, and also that both tapes have an equal charge. Initial values that we used was Earth's gravitational acceleration constant, 9.8 meters per second squared. The U-tape's length was always 8 inches, or 0.2 meters, and the tape mass ratio was 1 gram per meter, which we used to figure out the mass of the strip of tape. Possible errors that could happen during the experiment is accidentally touching the tape, which neutralizes it and causes it to lose charge, inconsistent charging of the U-tape, and the room humidity, which can cause static to not build well and cause errors in creating charge in the U-tape. Now for the experiment, where we try to calculate the amount of excess charge. So here's me creating a U-tape. So you have a base tape, and you stick it to the base tape, and then you rip it off. And when you rip it off, you create a charge on the U-tape. But you don't want to touch it, because the moment you touch the U-tape, it might lose the charge. So then the experiment, we had to balance the gravitational and electrical forces. So we had one U-tape on top connected on two ends, and it was kind of hanging down a little bit. And then we had the second tape, the U-tape, and I moved it below the hanging U-tape until the distance got close enough to where the hanging U-tape began to repel. And at that point, I recorded the distance between the different U-tapes, which I recorded as 6.2 centimeters, or 0.062 meters. Then I had to determine the charge of the U-tape. So I used a plastic pen that I rubbed against my hair. Doing that made the pen become negatively charged. And as you can see in the video, the pen and the U-tape attract each other. And we know that opposites attract, so we know that the U-tape must be positively charged if the pen was negatively charged. So here was the code that we used in GlowScript to simulate our findings and then calculate more information that we needed. So here was the program. So we created some constants that we used: the Coulomb constant, the gravitational constant, the mass of the tape, the distance between them, the number of atoms, and then we created our different points. So the tape B point, which was the hanging tape, and the tape A point, which was the one that we moved up. And then we created our force arrows, and then we printed out some different values that we want to calculate. So running this program, we got this, which shows us the different arrows on the U-tape up. So it has the gravitational force pointing downward, and then the electrical force pointing upward. And you can see that they cancel out because the U-tape was in equilibrium. So now for the discussion. So the question is, what if electrons had positive charge and protons had negative charge? What would change about the observations you made with your tapes and other charged objects? The only difference is that all positively charged objects will become negatively charged, and all negatively charged objects will become positively charged. Otherwise, everything else would be the same. Opposite charges would still attract, and like charges would still repel. The next question is, why is it important to handle the charged tapes as little as possible? What happens when the charged tapes comes into contact with your hands or other objects? So as we discussed earlier, when the charged tape becomes in contact with your hands, it can be discharged by the physical contact. So you need to be careful of that, because you don't want to neutralize the U-tape. Some comparisons between the real experiment in the GlowScript program is the program treated each piece of tape as a point particle with uniform charge. The program didn't account to loss of any charge by touch, and the program assumed only two forces acted on the system, which might not have been true in the real situation. Conclusions. So here are the calculations that I used, which we also ran in the GlowScript program to find the charge. And in summary, we found that the amount of excess charge in the U tape strip was 29 nanocoulombs.